Welcome back to another Daishinfinity video. In this video, we're going to talk about the scaling factor of infimum and supremum. So it states that a supremum of C times any number, any set A is given as C times the supremum of A. And that same thing follows for infimum, that the infimum of a C times a set A is actually equal to C times the infimum of A. So let's just start right now and prove this formula. And let's just first of all define what A is. So let A be a set which is not empty, and A is bounded. So A should be bounded by numbers. So we state that there exists a C in the real numbers. We have to take in consideration where C is bigger than 0 or C is smaller than 0, but I hope I'm going to do it right now for C is bigger than 0, and you guys can prove it for C is smaller than 0, which is just the analog to, change the signs, etc., etc. So what we have is we have to prove that the supremum, first of all, of C times any number set A is equal to C times the supremum of A. Now A should be in a subset of the real numbers. That is what we really want to have right now. In the complex numbers, it will be a bit more difficult to prove this. So let's just prove it for the real numbers. So let's define the C times A as a set. So I'm just gonna call it A star, which is just a set of all C times A where A is in A, which is a subset of R. Okay, so what we're going to do is we just have to prove that the supremum of C times A is C times supremum of A. So let's just let any variable S dash be equal to the supremum of A. Now, if S dash is a supremum of A, we know supremum of A is always the lowest upper bound of the set A. So for any small a given in A, so for any A in A, we can say that A is always smaller or equal to S dash. Now, the trick we are going to use is we're just going to multiply by C. So we just have C times A is smaller or equal to C times S. So we know that C times A is always smaller or equal to C times S. So C times S dash is always the smallest upper bound of the set C times big A. Now what we can do is, what we should actually do is to prove that C times S dash is actually the supremum. And using the supremum definition with the epsilon definition, we know that we have to prove it using epsilon. So let epsilon star be given as C times epsilon, where epsilon is bigger than 0. So epsilon star is also bigger than 0. Since this is true, we want to show that S dash minus epsilon star is smaller than A. This is like the definition of the supremum, since if we have any S dash here, and we have an A here, and if we just subtract something, then A is just immediately bigger than S dash minus epsilon for any epsilon bigger than 0. So this is just the the expression of the maximum. Now what we really have is C times S dash. So we just have to see what C times S dash is. So we know that C times S dash is the smallest upper bound. So C times S dash minus epsilon star is actually smaller than C times A. And the reason why I defined epsilon star is equal to C times epsilon is because right now, if we would divide both sides by C, we would get the definition of what we just wanted to have, the definition of the supremum. So from here we went to here, which means we can also go back and state that the supremum of C times a set A is actually C times the supremum of the set A. I hope you guys enjoyed the first proof. So for the second proof, we just have to, state or just prove that the infimum of C times A is just equal to C times the infimum of A. So let's just let A S dash, where the dash is, bottom, be equal to the infimum of A. Now, since A is not empty, S dash is also given. Now, since S dash is infimum of A, for any A in A, we can say that S dash is always smaller or equal to A. Multiplying by C would give us C times S dash is smaller or equal to C times A. So by the definition, we can say let another epsilon star be given as C times epsilon, also bigger than 0, since epsilon bigger than 0. So for the infimum, we know that for every epsilon bigger than 0, we can say that CS is immediately bigger when we have a C times A and we add an epsilon star to it. Now, this is what we want to have. We want to go from here to the definition of the infimum of A, such that, S dash is bigger than A plus a normal epsilon. Now, the reason why I actually define epsilon star, this is the trick to define it as C times epsilon, is because if we divided both sides by C, we can see that for every C in the real numbers except 0, S dash is bigger than A plus epsilon, which is actually the definition of the infimum. Or we can just define it as S dash minus epsilon is bigger than A. Both definitions are correct, but we just have proven that S dash is equal to the infimum of A. Yeah, and from that we can just say that the infimum of C times A is actually the multiplied C times the infimum of A. So I hope you guys really enjoyed this video. Please like and subscribe. If you have any questions, post them in the comments, and I will see you in the next Daishinfinity video. See ya.